So when we're dealing with different types of substances, there's different formulae that are usually going to be, the most useful, the most appropriate for given substances. So when we've got ionic substances, we know that empirical formulae are the most useful. If we're dealing with a chemical equation, then it's best to write the formula of an ionic substance as an empirical formula. However, when we're dealing with molecular substances, the empirical formula is very rarely useful. The empirical formula gives gives the simplest whole number ratio between the different elements in a substance. However, that's not really useful for a molecular substance because molecules have, full sort of structures, and we don't want to just sort of cancel it. We want to really, when we're dealing with chemical formulae, we really want to know all the atoms that are in the substance. When we're dealing with molecular substances, we want to look at the entire molecule. We don't just want to look at the simplest whole number ratio. For example, if we have here a sample of ethane, then the molecular formula is going to be C2H6, and the empirical formula is going to be CH3. Now, CH3 doesn't really help us a lot with this, because if this ethane molecule is going to react, then the whole thing is going to react. Whereas if we use the empirical formula, then that's really only representing one half of it, and we know that one half of the molecule can't react in that way. The whole molecule has to react, and then we might have a CH3 left over. However, we need to express it like this. We need to express it into molecular formula so we can really be aware of and understand and then analyze the way that the whole molecule changes in a chemical reaction. And for that reason, we need to use molecular formulae when we're dealing with molecular substances. Now, we've been through a few different ways that we can find empirical formulae of different substances. And so, we're all good at finding at now sort of calculating or figuring out the empirical formula of a substance. However, if that substance is molecular, then we need a way to convert that empirical formula to a molecular formula. So we need to be adding from the empirical formula to the molecular formula somehow. Now, this idea revolves around the idea, or this process revolves around the idea of molar mass, and the idea that empirical formula is the simplest whole number ratio. Now, because this is the simplest ratio, then we know that the molecular formula, we'll shorten that to MF, so the molecular formula is a whole number multiple of the empirical formula. So if we call this whole number Z, then the empirical formula is the simplest whole number ratio. And so the molecular formula is going to be sort of a whole number multiple. It's going to be a multiple of the empirical formula. And this multiple we're going to call Z. Now, basically, this Z value, we can work this Z value out using the molar mass of the if we know the molar mass of the molecular substance that we're dealing with, and we know its empirical formula, then we can work out this Z value. So basically, Z is equal to the molar mass of the molecular formula, which we'll again shorten to MF, divided by the molar mass of the empirical formula. Okay, so for example, in this up here, say we're told that the empirical formula of this substance that we're looking at is 15. Is CH3, and we know that the molar mass of this equals 15. Well, we can figure out that the actual substance we're dealing with is ethane, or C2H6, if we're told that the molar mass of the substance we're dealing with is 30. Because we know that, whatever the substance is, if that's the empirical formula, then the molecular formula must be a whole number multiple of the empirical formula. So here, if we were to do it in this case, if we were to do the molecular formula using this formula here, then the molecular formula is the molar mass of the molecular formula, which we know is 30. If we're not given this piece of information, we're just told we've got a molar mass of 30, and this is the empirical formula. Then we put 30 here, 15 here, and we multiply that by the empirical formula, which in this case is CH3. So let's do a proper example all the way through. So let's say that we've dealt with the substance, we've done all the experiments and tests, and from there we found out that the empirical formula of a substance is CH2. And we're told that the molar mass of the substance we're dealing with, so we'll call the substance the molecular substance, or the molecular formula. So the molar mass of the molecular formula is 98. So we've figured out that the CH2 is the empirical formula, and we've gained the information that the molar mass of the molecular substance, or the molar mass of the molecular formula, is 98.0. We want to figure out the molecular formula for the substance that we're dealing with here. So what we have to do is we have to figure out the molar mass of CH2. So the molar mass is equal to 12 for carbon plus 2 times 1 for hydrogen, so 14. And so if we divide these two, if we go here, we say 98.0 over 14.0, that's equal to 7. So basically we know that if we look at this empirical formula unit, or this small unit within the whole molecular formula, within the whole molecular structure, so here the CH3 is the empirical formula, and that's kind of like one base unit from which this ethane molecule is made. Here we've got 2 base units of CH3. Similarly, here CH2 is like the base unit in this substance, and we know that because the molecular substance is 7 times heavier than this base unit by itself, there must be 7 of these CH2 base units in the molecular substance. And so for that reason, we know that the molecular formula is going to be 7 times CH2. So 7 times CH2 is going to equal C7H14. So that is our final answer. What we're doing when we're converting from an empirical formula to a molecular formula is that we need to know the molar mass of the molecular substance. That's key knowledge. So that's key knowledge right there. The other part of key knowledge is the empirical formula. These are the 2 pieces of information we need in order to get the molecular formula. So if we know the molar mass of the molecular substance and we know the empirical formula, then we can use these to get the molecular formula. And we do that by comparing the weights of the molar mass of the molecular substance with the molar mass of the empirical formula by itself. And from there we can see, and we already know that the molecular formula is a whole number multiple of the empirical formula. And so the ratio between the molar mass of the molecular substance and the molar mass of the empirical substance tells us how much we need to multiply the empirical formula by. It tells us this Z value here. Tells us how much we need to multiply the empirical formula by to get the molecular formula. And that's how we convert from empirical formulae to molecular formulae.